Hey folks, in this short video we're going to use our knowledge of geometric series to write a repeating decimal as a fraction. So you may have noticed just the pattern whenever you type numbers into the calculator. If you type 4/9 into the calculator, it's 0.4 repeating. If you type 7/9 into the calculator, it's 0.7 repeating. And so you might be, if we start with 0.4, we can actually, if we didn't know it was 4/9, we can use our knowledge of geometric series to rewrite it as 4/9. And so first, what you may not realize is a repeating decimal is actually a geometric series. And let me explain what I mean by that. If I have 0.4 repeating, we know that that's 0.4, 4, 4, 4, 4 on forever, right? Now, couldn't I rewrite that as this? 0.4 plus 0.04 plus 0.004, right? Isn't that just all that's going on? We just add one more place every time. Now, this is a geometric series because our common ratio here, the number that we'd multiply by, is 0.1 or 1/10. Because you know if you divide by 10 or multiply by 1/10, it's just going to move your decimal over one place. So what we have here is 0.4 repeating is actually a geometric series with a first term of 0.4 and a common ratio of 0.1. With that knowledge, we can just substitute those in to our formula. We know that to find that sum, we take our first term of 0.4 and divide by 1 minus the common ratio of 0.1, which that becomes 0.4 over 0.9, which is 4/9. So that's how we can use our relationship for an infinite geometric series to rewrite a repeating decimal as a fraction. I've got one more example. Because what if it was one of these that said 0.37373737? So I want you to pause it, maybe try this one on your own, and then whenever you're ready, hit play and see what happens. But I'm going to go ahead and get started. What we have is we have 0.37 repeating. Like I said, is equal to 0.373737 dot dot dot. But what we could do there is we could do 0.37 plus 0.0037. That's the only caveat that differentiates this question from the previous one. Plus 0.00037, on an infinite number of times. And so we've got our first term is 0.37, but then our common ratio here is not 0.1, it's 0.01. So now we're multiplying by 1/100th every time to move that decimal over two places. Now, armed with that knowledge, we know that our relationship is going to be our first term divided by 1 minus the common ratio. Well, our first term is 0.37, our common ratio is 0.01. That means that this would simplify to 0.37 over 0.99, which is 37/99. So that's how we could rewrite the repeating decimal 0.37 repeating as a fraction.